Okay. So, okay. This is an exercise where you would generate numbers of male and female based on a ratio that is mentioned here. This is a common ratio between males and females around the whole world. So we have before use random method to be able to generate random numbers. So we need to keep generating numbers, and we have to decide based on the output here. This number is actually goes to count for males or for females. So you have to decide. This random actually generate numbers from 0 until 0.99. Am I right? So you have to think and decide. If it is from 0 to what, you consider the output as a male. If it is from what to 0.99, so this is the range for males. This is the range for females. So we have to decide from 0 until what number, and from this X number here to 0.99, so it will be considered in female. So we have to generate first a number, and then we check this number. If it falls within a certain range, so we need to increment the male count by 1. If it falls into another range, which is this one, we have to increment the male count by 1. So this is a simulation for a population. So as we run the program, we need to record the results in a table at the bottom to simulate the population sizes of 1,000, 10,000, and 100,000. So it means that he is telling you, try to simulate the population. If we have, first of all, did you understand anything from what I'm trying to tell you?
I don't understand this, the male and female, the 0 to X and X to 0.99.
Okay, forget about that at the moment. If you have, okay, first of all, are you able to create a method that call the random method here for 1,000 times and 10,000 times and 100,000 times? So this is a simulation for the population. So, okay, and this is the first step. If you're able to do it, then we move to the next, which is, he is telling you, you need to know the percentage of males and females in the total population. Random numbers, as I said, it produces numbers in this range. So just why it produced in this range from 0 to 0.99? That is what Java is doing. So it's not me decide. What you need to do is that you call math.random and see what is the output. Okay. So I would say I would initially just give you this copy from here at the start, and then I would like you to start sharing your screen, and then I'm giving you this code here.
Okay.
Math.random is actually a way that can simulate people who are playing the dice. When you throw the dice, every time you throw it, it come up with a different number, right?
Yeah.
Okay, so actually math.random is one of the ways to simulate that every time you throw the dice, it come up with a different number. And yeah, so
okay, so now you want me to just randomize it 1,000 times.
yes, call the random master.random for 1,000 times, and I want you for once to print the output from master.random when you run it, to see what is the kind of values that can come out. We have done something similar before, right?
Yeah. So I can't make it integer, right?
You try to make it keep it as double. Master.random produce a double value, so keep it as a double, yes, and just print it out.
Right.
Run again. So every time we are producing a number between 0.00 until 0.99.
Yeah.
Okay, good.
Do I
So
want to limit the decimal places or just leave it?
no, not our interest at the moment.
Okay.
You can do that, but not in this moment. So now, are we able to run the master random for 1,000 times
Yeah.
in a loop?
Oh, okay. Uh, so I think I should make a new method and call it
Okay,
edge.
fine.
Or can I just if I make this actually take this loop. So you want it how many times you want it? 1,000.
Yeah, start with 1,000.
But if I put 1,000 and then if I put math random here, it's gonna take so long to print out 1,000 math randoms, right?
Not really. No, it will be just a blink of an eye.
Yeah, that's true. Okay. Yeah. But it would be such a huge
Yes,
book
definitely.
size.
Yes.
Okay, so that should work. Oh, actually, it has to be 1,001. So this is not equals to.
Okay.
Yeah.
Okay, but the problem now is that you actually printed the same number for 1,000 times,
Oh,
but that's not our interest. Our interest is to
oh,
generate
oh.
1,000. Makes sense.
Oh, yeah, but that's too many. Yeah. I want to tell here and do is it N, right, for a new line? And then
Yes,
T for space, yeah. Okay.
N, but you have to put it in a double quotation.
Yeah. Oh, yes. Why can't I just have one? Sure. Okay.
So normally, if we have text, we need to add the word plus. Yes, excellent.
Yeah. Okay.
Mm-hmm.
So it works now.
Okay, so now we are managed to generate 1,000 random numbers. Am I right?
Yeah. Yeah.
Okay, good. So let me think. To be able to use these randomly generated numbers, I want to you to think in this way. Huh? This is a numbers that lies from this range, right? We already know that. If I would like you to use generated numbers to actually generate or tell me if what we generated is head or tail, how would you think about that? Can you use this randomly generated number to actually do this simulation for the head and tail?
Yeah.
You know the head and tail, right? When they
Can.
toss a coin, okay, how can you modify that?
Wait, I need this. Okay. Okay, so I don't need to print out. Um, Bubble. 91. Oh, but I don't want this to be in the like I don't need this, all this. Wait, wait, this whole thing. You wanted heads and tails, so it should be like that, right?
Why you need to I mean, you was moving correctly actually. Yeah,
You get a random number.
yes, you want to generate 1,000 random number, and you would like to know how many times it come out as a head and how many times it come out as a tail.
Oh, you want to know? Oh, okay, okay, okay. So how many times head,
I
how many times tail? Okay.
Yes, so because we're talking about probability, we would like to see the probability of getting it head and getting it as a tail if we run for 1,000 times. So how would you do that? First, if you run like that, it's not bad to see what is the output instead of just having numbers. Yeah.
Oh. My if I didn't yeah.
Okay, so we start to make sense of what we are getting out, but it's better to have a count. It means that we need to account for heads and we count for tails.
Yeah.
Because
So what
if
I
we would like
do,
if we look here, we never know how many times heads come out and how many times tails come
so I
out.
just want integer one head.
Mm-hmm.
Oh wait. No. Yeah, okay. That should work. Yeah. Let's see how it works on that. No.
Okay. A slight modification. This is correct, but it need to go out here. So
Yeah,
it should not be repeated in the while loop. Just
yeah, I
after,
accidentally put it inside the
no problem.
okay.
So you see here, we almost close to say that they are almost like okay, 48% to 51%. So this is the probability of having a head as a result and a tail as a result. This is the probability.
Yeah.
So the more you run, this changes because this is a random generated numbers.
Yeah.
Okay, but they are slightly close to each other. Am I right?
Yeah, they're close.
Okay, good. Now, if I would like to tell you, instead of talking about head and tail, I would like to talk about male
Male and female.
and female.
Okay.
So just change.
Okay. Then
Okay.
technically you also want like a total population. So I should add like this.
Interesting. Excellent progress. So far, excellent progress. Okay.
Yeah, wait, I need brackets.
Yes.
Okay.
Okay, good. So I just because the exercise, if you see, he tell us, okay, we start with 1,000 running, and this number will change. Are we able to mix our male and female simulation? as smart enough so that we get this number as an input. So we don't have to rewrite it here.
Okay.
We just pass it as an input. Can we do that?
Yep.
Manipulation, okay. And then good.
Then just put,
Yes.
oh wait,
Okay.
but I need to add, actually, I just make this equals,
Yes.
okay.
Okay. So you run, it will run
There you go.
perfect. Now the trick in this exercise, of course, you can able to change here from 1,000 to 10,000 or 100,000. There is no
Yeah.
issues about that. But it will take
Yeah.
slightly longer time, but it will work. Okay.
Yeah.
Now you are trying here to divide equally the amount of, so you see here, you say, okay, half of the numbers will make up the males, the other half will make up females. But what if we have a bias? I
Yeah.
understand this is more to statistics, but okay, it's part of the programming course that you might study. So
Yeah.
the bias here is a tendency of a certain part of the population to become bigger than the other. So the male actually percentage in this word is 51.9. So actually,
Right.
to be able
I
to,
should change this
yes,
to 519.
yes, exactly.
Okay.
So that will give a bias to the males to become more. So now you start to see here, this will
Yeah.
always be bigger than this one.
Yeah.
Okay, does this make sense so far?
Yeah.
Okay. Let me see. Let us try to take something new in the remaining minutes. Let me try to share something with you.
Okay.
Okay. Are you able to see that example? This is a method. So if we want to make a for loop to print numbers that is multiples of 4 up to 40. So this is one way to do that. And this is a second way to do that. Tell me if you can really understand the difference between this method and this method. This is not a method. This is like an algorithm or a way of thinking. We print numbers from 4 until 40.
Yeah. Okay, then second. Right, okay.
What is the difference between this line and this line?
So that they both work, but that one, like the first line is they take the 4 and they just keep adding 40 because just keep adding 4 because multiples of 4, right? So
Yes, so it means
they
that he
keep,
do it in one compact line. He do
yeah,
everything, and
yeah.
here he do the same thing, but he is
He get
incrementing by
one
one,
first, and
and
then
then
only he will, yeah, get
so
rid of all the ones that are not.
yes, exactly, and he will not print it out. So now,
Yeah,
which one is more clearer to in your eye? This
the first one is easier.
easier, right? Okay, good.
Yeah,
So okay, now okay, we have taken something like this. So if we want to use decrementing for numbers in the for loop, this is how they write it. Can you look at it and tell me? We have done it in a while, if you can remember, just a while ago. So this is the
yeah.
equivalent of that in for loop.
Okay, so integer I. Yeah, to make it count down. Yeah, that's what I did to make it count down. Yeah, man. So this is just in a full Okay.
just in one line.
Yeah.
Okay, do you see the difference in the condition? He have to reverse the condition.
Yeah.
Okay, good.
Because when I didn't reverse it, then I got like infinite numbers.
Exactly, yes. This
Yeah.
is in the while, yes. Okay, now have a look at the prime, but this is using a for loop, not a while loop.
Right.
This is
Okay.
exactly the same, except that he changed while with a for. So it's slightly compact
Yeah.
here. Okay, good. You understand it.
Oh, 1 second. Yeah. Okay. Yeah.
Okay. Now, I would like you to look here at this line, these 4 lines,
Yeah.
and tell me, are we able to simplify it more?
Probably not. I don't know. It looks quite simple.
Okay,
I don't
but
know how
actually,
to.
so I understand that this might be slightly not so obvious and maybe not so preferable, because I myself also find it not so clear when I started to learn programming. So that 4 lines in the previous page can be actually replaced by this one line. So instead of returning true and false,
Right.
you just pass it this equality check, and based on the
Right.
result, either true or false, it will return it.
Right.
So is it clear to you?
Yeah.
Are you able to understand it easily, or the previous one is more simple?
Uh, both is okay. I'm just more used to the previous one.
Okay. So again, he's trying to compare between the while, the for, and the while. And
Yeah.
so if we want to compute the sum of numbers from 1 until 100, so
Yeah.
actually the one who is more suitable and compact is to use a for loop.
Yeah.
We use a while loop if we don't know when this while loop will end. But if we know upfront that we only have 100 numbers that we want to sum, so it means that we
Yeah.
know when this loop will end. So we should always use for loop. So for loop, if you know how many times this line will run, if you don't know upfront how many times this loop will run, then you use a while loop.
Yeah.
Okay, so can you understand both loops now? I mean, these codes, code 1 and 2, they are
Yeah.
doing exactly the same thing, but here it's slightly compact, if you can notice.
Yeah.
Okay,
Yeah.
good. Let me see. Can you understand the code that you see here in the screen?
Yeah. So it puts you in a loop if x is less than 0, then it just puts you in a loop again to enter the number until you
Oh,
enter a positive number.
okay, fine. But why we didn't use a for loop?
Uh, because if you use a for loop, you have to add like because you don't know how many times you're going to loop it, but if you use a for loop, you need to add a number of loops.
Okay, my question now, why we don't know upfront here how many times we're going to run the loop? It depends on what?
It depends on the input. You can
From the
put
user.
10
So it's
negative numbers. Yeah.
okay. So only here we are able to use a while, we cannot use a for, right?
Yeah.
Okay, so that is the purpose of that class so far. Do you
Yeah.
have any questions so far?
No.
Do you feel that you are progressing? And if you feel
Yeah.
that, how by how percentage do you feel you are progressing?
Uh, I feel like I'm getting a lot, like we are not progressing too fast, but I'm getting stronger at what I know. Like this loop. Last time, like maybe before this class, I was weak on the loops, and now I'm strong and I know a lot more about how to use the loops better.
Okay, so if you were to choose between a balance of running more exercises until you feel that you are more satisfied, like what we are doing now, or
Yeah.
progressing on the subject much faster, which one you choose?
We can go a bit faster.
Okay, you want us to go a bit faster, so
Can?
it means that
Yeah.
we take less exercise.
Yeah.
Okay, good. Okay, we can do that. Yes. Okay.
Okay.
So see you
Yeah.
next class then. Take care.
Okay. You too. Okay,
Bye
bye.
bye.